Hi everybody, today we're going to complete two lessons, 1-8 and 1-9, and these are the 5 objectives for today. So write them down and check them off as you learn them. So let me just set this up. And so the first thing we're going to do is learn to classify equations as true, false, or open. And by now you know that an equation is any math sentence with an equal sign. So we say an equation is true if the left side is equal to the right side. An equation is false if the left side is not equal to the right side, such as 7 times 8 is not equal to 54. In the third example, this is an equation with a variable in it, and we say that this equation is open because we don't know whether it's true or false. It depends on the value of the variable. So whatever x is determines whether the left side is going to equal to the right side or not. The second objective is to write better equations with 1 or 2 variables. Now I know that you already know how to write equations, but some of you may not be writing the nicest equations possible. Remember, we're not just trying to write an equation, we're going to write beautiful equations. So to start off, you must define your variables and you must be as specific as possible. So for example, you're going to say let x be the length of boxes in inches, or y be the height of the pole in feet. And notice that I'm very specific as to what x stands for, whether it's inches or for y it is feet. So be as specific as possible. Of course, your math sentence must have an equal sign, otherwise it is not an equation. The variable must not be already isolated. So many of you write sentences that look like 10 minus 2 equals x. This is not an equation. This is actually just a calculation. It's telling me in order to get x, I have to take 10 and subtract 2. This is a very bad equation. The better equations are 10 minus x equals 2 or x plus 2 equals 10. So how do you know that your equation is nice? And that's what you're going to learn. I like to teach my students about these triangles, so it helps you understand how to write better equations. The top of the triangle always has your largest number. So in this case, 10 is the largest number. Here 15 is the largest number, and here z is the largest number. And so the worst type of equation you can write for the first triangle is 10 minus 2 equals x. The better way to write these relationships are x plus 2 equals 10 or 10 minus x equals 2. Can you try to write the worst equation for the second triangle? Of course, the worst is 15 divided by 3 equals p. So you're going to rewrite it, make sure the p is not already isolated, and you will end up with either 15 divided by p equals 3 or 3p equals 15. In the third triangle, I've set up only variables, and we just want to make sure that the variable on the top is the largest value. And then the relationships can be written in these 3 different ways. Hopefully you can write good equations. So now we're going to learn how do you write equations for a word problem. Because we are writing equations, you need to always look for 2 things that are equal to each other. So we're going to just do this problem from your textbook. This is in your textbook. You do not have to copy the word problems down. So it says that the length of a ball court at La Venta is 14 times the height of its walls. Write an equation that can be used to find the height of a model that has a length of 49 centimeters. In this equation, we have to find the height of the model. And since that is what you have to find, you are going to write your let statement as let h be the height of the model in centimeters, and you know it's centimeters because it tells you in the problem. Once you have written your let statement, you're ready to write the equation, which is 49 equals 14 times h. So I want you to try one. An athlete trains for 115 minutes each day for as many days as possible. Write an equation that relates the number of days d that the athlete spends training when the athlete trains for 690 minutes. In this case, you do not have to write the let statement because the problem is already giving you the variable. Therefore, you are only responsible for writing the equation. And the answer happens to be 115 times d equals 690. The next thing we're going to make sure you know how to do is how to write equations for a table. Remember that in a table, the x is the independent variable and y is the dependent variable. Now, tables are written in two ways. You could have a vertical table or a horizontal table. And depending on whichever is convenient, you can choose either one. The vertical table is also known as a T-chart because these lines are in a T. So let's show you one table and see if you can figure this out. So here we have some x values and some y values, and in order to make sure you can do them properly, you want to make sure your x's are going up by ones, and this actually helps you to find the unit rate. And your y's starts at 2, then goes to 3, then goes to 4. It turns out that the rate here is 1, and your equation is going to be, you need to guess it before you see my answer, and this is y equals x plus 2. This ordered pair where the x is equal to 0 is very, very important because it gives us the starting point. So let's see if you can figure the next one out. Here, make sure again that the x's are going by ones, and look at the y values, and let's see if you can figure out this answer. And it is y equals x plus 6. Now we're going to determine whether you should connect the points on a graph or not. So determine if a graph is discrete or continuous. Continuous means all connected. So discrete means a graph when the points are not connected. So here's an example, and this is from your textbook. If the number of blue tiles is going up from 1 to 2 to 3 and 4 and so on, and the total number of tiles is going up in this manner, when you go to graph this, will this graph be discrete or continuous? That is, should we connect the points? And the answer to this is, it will be discrete since the function exists for whole number values only, which means that you cannot have 1.5 tiles or 2.25 tiles. Since we can only use whole number tiles, when you plot this graph, you're going to get discrete points. Here's another example, and you must copy these tables in your notebook. Let's say we're comparing two people's ages, Carrie and Kim's age. When you connect this, when you plot these points, will you have a continuous or a discrete graph? And this one is going to be continuous because x and y values exist for numbers between the whole numbers. What it means is when Carrie is 1.5, Kim is 3.5, and so on. So for every x that goes up, a y also goes up. And this is your homework for tonight. I am going to add another set over here, and that is going to be numbers 17 through 24. Make sure that you label your graphs and you approximate the values if you have large numbers. That means you can sketch the graph if required. And I'll see you in class tomorrow. Bye-bye.